Consistent hashing is a really important concept in distributed systems. It's used, for example, in load balancing, database sharding, to name just two examples. In the next 4 minutes, we're going to cover exactly what consistent hashing is and why it's so useful for these distributed systems applications. Enjoy, and I'll see you in 4 minutes. So first, let's talk broadly about what hashing is and what hashing does. Hashing takes a hash space of a determined size and divides it into a set of buckets. Then, using a hash function, it maps any given value into one of the buckets on this hash space. And depending on the hash function you use, what it should do is spread those values, provided the input is not skewed. It should spread those values out relatively evenly among the buckets. Now, the final part of any hash function is a modulus, where the modulus value is the number of buckets in the hash space. This is how we ensure that any given value fits into this hash space and into one of the buckets. In traditional hashing, if the output of the hash function is slightly skewed, then one of these buckets might become more full than the rest. So in traditional hashing, when this happens, one of those buckets becomes full. The way that is remedied is by increasing the number of buckets by increasing the size of the hash space. So now we add another bucket, like so, increasing the number of buckets in the hash space. The problem with this is that the hash function depended, remember, using that modulus value on the number of buckets. So when the number of buckets increases, now all of the values mapped onto this hash space are invalid and they need to be rehashed, remapped to get their new bucket for this new larger hash space. And the same would be true if we took one of these buckets away here. The problem with this is that hash functions are expensive to compute. They take a long time, a lot of compute resource. Computing every single value that we've already hashed is going to take a lot of compute resources, could take a good amount of time. In contrast, consistent hashing uses a fixed hash space which never changes. This is often represented in a ring like that. Now, in this ring hash space, the space is still divided into buckets, which are spread out along the hash space, but the size of the hash space is always finite, and values are still hashed and mapped onto this ring and therefore given a bucket. But the modulus operation is the size of the ring, not the number of buckets. So when one of these buckets becomes skewed, or rather too full, we can instead just divide that bucket in half, essentially splitting it into two. Now all we need to do is rehash the values in this original bucket to determine which new bucket they fall into, rather than with traditional hashing where we had to rehash every value in the space. So the key difference between consistent hashing and traditional hashing is that the modulus value in the hash function uses the fixed size of the hash space rather than the number of buckets in the hash space. This means that rather than having to rehash every single value which has been mapped onto the hash space, we only have to rehash those values inside the bucket which has been split. And that's consistent hashing, how it works and why it's so useful in distributed systems applications. If you enjoyed this video or this format of quick explanations of engineering concepts, be sure to give this video a like, a thumbs up, so that everyone else can find this video and learn about consistent hashing as well. If you do have any questions or thoughts about consistent hashing or these quick explanations, be sure to leave those in the comments below. I will be getting back to everybody who leaves a comment there, so please do that. If you do like this format of quick explanations, then be sure to click subscribe. There will be plenty more coming in the next few days. And finally, if you haven't seen yesterday's video, which was about Kubernetes and how Kubernetes works in 4 minutes or less, I'll leave a link to that video right here so that you can go and take a look at that as well. Thank you so much for watching, and I'll see you soon.